So today we'll be demoing Proficy Smart Factory for discrete, where we'll be going over a manual complex process with our theoretical part called our Acme radio. So the first module I'm in here is our route editor. And the route is really the path of work that we're defining for our order to follow. And along this path of work, this is where we're defining our quality checks, any bill of material consumption along the way, as well as where the work actually occurs in terms of our plant model. Now, when we go to our route editor here, we can see that we have a couple of different tabs. So we have our drafts, we have our routes that are pending approval, as well as our release routes and archive routes. The route that we're going to be working with today, that's our standard here, is our Acme discrete route. Again, this is our theoretical radio part here. And here we can see that our route is made up of three separate operations: our assembly operation, our test and inspect operation, as well as our package and ship operation. And within these operations, you can see the individual equipment areas of where this work actually happens. So in Operation 10, this occurs at our assembly station. And Operation 20, this happens at our quality testing area. And our Operation 30 is our Acme shipping area. Now, the next tab here is our attributes tab. So this is really where we can define our labor types specific to our operations. So right now we are working with a released route, so I'm not able to make any changes. But within this attributes tab, I could change my labor type to direct, which means there's a technician that's actually going to be working on that operation. Indirect, which means it's going to be a machine running the entire time, or also rework. And we also have the ability to change labor types and create new labor types as well. Now, what we can also do in the attributes section is make operations optional, parallel, as well as mutually exclusive to support dynamic or complex routing. Now, if I jump to my resources tab here, and if I go to my operation, what we can see are the standard times that I've actually built into this routing. So these standard times are what we expect our operators or machines to complete the work in time by. So in this case, for our assembly operation, we can see that we have 10 minutes of setup, 20 minutes of runtime, and then we don't have anything for inspection or transport. But once we have these standard times associated to the routing and operations, then we can compare the actuals that we collect in the actual order, and we can find out a performance metric. Now, if I move to my bill of materials tab here, we can see our bill of material that we're going to be working with today. So we have bill of material made up of a bolt, a circuit board, as well as a machined plate. And so here in the route configuration, this is really where we're defining where this consumption actually happens. So in this case, we want to define that all of the consumption happens at the assembly operation. And then if we move to the right-hand side, we can also see things like our unit of measure, as well as the assigned quantity. Now, if I move to my Documents tab, this is where I can see any of my work instructions that will be viewed as a technician actually walks through an order. So here in the Documents tab, we can also define where these documents are actually viewed. For example, this sample document is viewed at the route level, so at any point in the order. And then this radio assembly work instructions here, these are viewed specific to the assembly operation. So we can define at a higher level, but also down at the operation level. Now, if I go to my variables tab here, this is where we can see all the quality checks that we've defined for this route. I can bring this down by specific operation as well. So here we can see the 4 variables that are going to be captured for the assembly operation. And then here are another 5 for the test and inspect operation. And again, right now, this is the configuration piece of setting up the route. And now we're going to jump into the actual execution, so creating an order based off of this route. So I've already created an order in my system here, but if you're new to creating an order, what you can do is in the route editor, navigate to the three dots, and you can move down to create work order. And then you can give your work order a name. You can give your work order a planned quantity. You can define your serial and lot prefix, as well as defining your actual serial and lot number. So for example, just call this work order test. This one will define our serial prefix, and then from there, define our actual serial and lot number. And so this is the information that would be needed to create an order. A lot of times I talk to customers here about how you can create the orders within the system, but also this is where we receive the information in from the ERP system. So this is the information that our system looks for in an ERP integration in order to actually create an order. But I'm going to navigate to an order that's already been created. So we're going to jump back out here and go to our work order manager. And so our work order manager is really where we can see any released, any on hold, or completed jobs within the system. So I'm going to go ahead and move over to the order that we're going to be working with today, which is our work order-Acme Radio-3010. Now, if I click on my order here, what we can see is a specific summary of that order. So we can see the three operations that were defined in the route editor. Here we can see that we're ready to clock on to operation 10, but can't complete operation 20 or 30 until that first operation has been completed. If we move to the right-hand side, we can see some of the characteristics that will be collected as we actually work through an order. So for example, we'll collect things like our started time, our completed time, the quantity that is actually completed, who completed the operation, as well as the overall duration. So this is the information that will get picked up as we go through that order. One thing to also note is if you do hit this drop down in the work order summary here, what you can also see are the associated planned start, planned end dates, which then you can then compare to the actual start and actual end dates. Now, these are key pieces of data if scheduler is involved in engagement as well. Now I'm going to jump back here and we're going to move to the actual execution piece. So we have an order that is created and now we can actually begin on that order. Now we have two different views of where we can actually execute on these orders. So two different modules. So the first is our work queue. Now the work queue is really a higher level view of all the work within your facility or all the work that you want to filter down to. So this, for example, is for someone with an iPad that's moving around the facility and they want to clock on to a job at a certain area, then maybe move to another job, or maybe this is just a supervisor viewing all the current jobs that are working or being worked on. Now, if we move to the unit operations tab here, this is really where we can start to get more granular and filter down by specific equipment area. So here we're taking a look at just our assembly station. So right now, what we're simulating is a technician sitting at that assembly station, looking at a desktop or iPad, and they can see all the jobs that they have in queue and that they have to complete. Now, what we can also see are the different statuses of the jobs. So here you can see that we have a single clock on from one operator. But if we move up, we can see that we have an order that's currently in progress where multiple operators are clocked on. So we can support a single order or job being clocked on by multiple operators. And then we can also support a single operator moving around and clocking on to multiple jobs. Now I'm going to go ahead and start this job here. So our Acme Radio-3010. I'm going to go ahead and clock on, and what we'll see right away are the work instructions that I need to follow. So here, as a technician, I'd be able to read or be able to interact with my actual work instructions. Next, I'm going to move to my bill of material tab here because this is an assembly operation. Here, I'd be able to see any of the bill of material or parts that I need to consume in order to actually create my overall assembly. So in this case, we currently have a bolt that we need to pull from inventory or that we need to kit. So in this case, we can hit our search button here, and what we'll see is we get that bolt-lot-xy, which has 38 bolts available for us to consume. So here I'd be able to actually consume my bolts and simulate sending that data back to the ERP system, where we've now told the system we've actually done that consumption on the shop floor and the parts have been taken out of inventory. What you'll also notice here is if I highlight over this little camera icon, you can see that we have the ability to scan barcodes. So what I'm doing right now is very manual, but the scanning process is a way to expedite all of this. Now I'm going to go ahead and consume. And as I exit out of this, what we'll see is that specific serial lot number here that we've consumed from. So we've taken those 4 bolts out of our inventory. Now I can do the same thing for my circuit board here. So we'll say that we've scanned our circuit board -02, and we can go ahead and consume. And then we'll do this one more time for our machined plate. Here we currently have some plates that are in inventory, so we're going to consume from there. So now that we've filled out our bill of material consumption, we can move to our quality tab. What you'll also see is that red alert, so the one here circled, that means that we have a mandatory quality variable that we must fill out. So as I hit pass here, what we're going to see is that icon disappear. Now next, I'm going to go ahead and fill out another variable. So here we'll say tool X has a dent on it. We're going to verify that we followed all of our procedures, and now we'd be able to clock off of this job. Now, if you follow my cursor, what you'll also notice is that we have a lot of standard tabs. So everything to the left of the cursor here is out of the box functionality. Now, what we also have the ability to do is build in custom or configurable tabs utilizing Operations Hub. So for example, maybe I want to monitor a machine as I'm actually working through an operation. Here we're simulating that connection with our historian, pulling data while we actually do work on the shop floor. Now, there's a lot of different use cases for Operations Hub here. Some customers like to create complex displays, and then others also just like to simplify the UI. So say, for example, if you want this quality screen to just be a tad bit more simple, maybe you just want one large button where you either scrap parts or where you create a non-conformance. That's also possible with Operations Hub. So it could be one large button where you're just making that user interface more simple. Now, another example we have here is a 3D drawing viewer. So really what we're simulating here is a customer who wanted to extend those execution capabilities and wanted their technicians to be able to interact with a 3-dimensional model of their part as they walk through that process. So I'm going to go ahead and clock off of this job. And so based on that routing that we talked about in the beginning of the demo, we're now going to move to the next area. So the routing then sends us to our quality testing area. And so as a technician now sitting at the quality testing area, I'd now be able to clock on to that Acme Radio -3010. So here I can go ahead and start my job. And we're going to move to the quality tab as this operation is more so specific to quality. So what you'll see here right away is that data populated automatically. So here what we're simulating is the connection with our data historian. So how we can ingest data coming from PLCs, coming from machines, coming from smart sensors, where we can bring that data in and automatically capture it in the MES. So what we're truly simulating is a technician putting a part down on a smart scale. And that scale then sends the data into the MES to be contextualized to a specific quality variable. Now I'm going to manually input this variable, but what you'll see here is we also have the concept of calculation variables. So this is a very simple calculation, but these can also grow to be complex. Now, if you follow my cursor, what you'll also see is we have the concept of specification variables. So these are variables with limits. So here, if I were to put this within spec, you can see we get our blue box and that we're on target. But if I were to put this out of spec, what we're going to get is a red alert. And then if you follow my cursor, you can also see that we're out of spec on our graph. Now, if I were to try to clock off of this, what the system is going to tell me is at least one variable is out of specification. And so this is an example of some of the defense mechanisms that can be implemented within the MES system. Now that we have a nonconformance, we can go ahead and use our create nonconformance button. Here we can utilize a summary. So we'll go ahead and call this NC-LB-video. And I'm going to choose a defect type, and these are all configurable based on customer logic and business processes. So I'm just going to go ahead and say torque inspection failure. And then based on our defect type, we can choose a reason. So I'll just say machine failure, but you can see the different levels of the reason trees that we support. Now we get a simple summary here of that failed criteria. However, if I were to move to my additional information tab, what I can do is either add comments, I could take a picture, I could take a video, I could upload an attachment. And then we also have the concept here of an edit image button. So if I want to circle a nonconformance on a picture or draw an arrow to add additional context as to what happened on the shop floor, I can do that as well. So we're going to go ahead and submit our nonconformance. Now, what we'll see is as I move back, our 3010 here is currently not in queue. But if I do move to my on hold section, here we can find that order that we had been working on. And we're currently on hold because of that nonconformance that was created. Now, because of that, we're going to move to our nonconformance manager module here. And so this is where someone in operations management or a quality engineer, quality manager would sit. This is where they can see any open nonconformance within the system. So again, here we see that Acme Radio -3010. Now, what we can do is basically decide what we want to do with this part. So what we call dispositioning. So as we disposition a part, there's a couple of different processes that we can choose. So we can clear a part, which means we made a mistake. It wasn't actually a nonconformance. We can continue to process, which means we know it's a nonconformance, but we still want the part to continue downstream until we choose what we want to do based on an operation. We can also scrap a part. We can use as is. We can also rework a part, which is basically where we have the ability to add new operations into the overall order routing structure. So what I have the ability to do here is create that new operation. So with our torque value issue, what I could say here is rework torque. And I'd be able to choose my specific equipment area based on my plant model. I'd be able to add any new documents. I'd be able to add the variables or quality checks that I want to happen in this rework operation. Now, say you don't want to go through that process of building out all these new operations. What you also have the ability to do is to utilize what we call change specifications. So if you have a common nonconformance with a common rework, you can utilize these change specifications basically as rework templates. So here you can see the 3 operations that were populated automatically, where I can see things like the sequence, the name, the description, as well as the equipment that I could now save as a change specification and I can utilize on the shop floor. So this is really a way to build in that rework template and a way to avoid manually building out all these operations with the specific information included. Now I'm going to go ahead and we're going to use as is here. That's going to be our disposition type. So what we also have the concept of is approval workflows. So if you are dispositioning a part, say as a quality engineer, and you want to send your disposition to your quality engineering manager, to your operations manager, you can set up that workflow within Plan Applications. Now we're going to go ahead and select a reason for why we're using as is, and we can go ahead and say the customer told us that it was okay to do so. So we're going to go ahead and submit here. And so what we'll now see is that status has changed to closed. So if I go back out onto my theoretical shop floor here, if I go back to my quality testing area, what we'll see is that Acme Radio-3010 has now moved back to open. And so now, as an operator, I can continue my work here. And what we'll also see is that torque value 2 that was out of spec is now grayed out. I can't make any changes to it. But now I can finish up my job here and we'll go ahead and clock off. Now we're going to move to one more operation, and this is our shipping area here. And so this last operation is really built in just to showcase the e-signature capabilities. So I'm going to go ahead and clock on to our package and ship operation. I'm going to fill out my packaging visual inspection. So we'll go ahead and say pass. I'm going to authenticate myself as the performer. So that's going to be ophub admin. Try that again. And I'm going to hit approve. And now we're going to authenticate the verifier. So this has to be someone else. So we'll say Comex client. And then I can go ahead and approve this. And so what we'll see is that eSig has now been completed. And now we can officially clock off of our job here, which completes our order. Now, what we're going to do is go back to our work order manager just to summarize some of the work that we just did and talk about the data that did get collected as we moved through that order. So if I go to my completed tab here, we'll find our Acme Radio-3010. And what I can do is take a look at my summary. I can see what data has been collected. So the start time and the stop time of the actual individual operations, as well as the completed quantity. So here we did not scrap anything. We can see who actually completed those operations, as well as the overall duration. Now, what I can also do is move to my non-conformance tab, and what we'll get here is a quick summary of the issues that actually happened on the shop floor, as well as the disposition information. So the work order summary is really a single pane of glass of where we can tie a lot of that information that gets collected on the shop floor in, and where we can access that information. Now, so far, what we've done is we've walked through the route editor. So we've set up the structure for an order. We've executed on an order. So we've walked through the individual operations. We've talked about the operator interface. And now we've just summarized some of that work that we've just did in the work order manager here. Now, the next piece of the demo is really just jumping into some of the out-of-the-box reports and out-of-the-box visualizations so we can take a deeper look at the work that we just did. So the first module I'm going to jump into here in terms of reporting is our genealogy module. So I'm going to go ahead and look for my Acme Radio-3010. We'll go ahead and add this to our genealogy board here. So what we'll see at a quick glance is our work order details. So this is just some additional information. So planned start, planned end, actual start, actual end. What did you actually complete in terms of quantity? What did you actually scrap? What was planned? Now, what's powerful here is if I move over to my graph or my visualization, So here we can see a visualization of the consumption that actually occurred on the shop floor in the earlier part of this demo. So here we can see our bolt-lot-XY that we consumed floor from. We can see our circuit board -02, and we can see the machined plate lot that we took two machine plates from. And overall, that now makes up our Acme Radio 3010. Now, what I can also do is work backwards. So if I click on my bolt-lot-XY, we can also see this lot of parts started off with an original quantity of 50. And we've now gone down to 34. And those 16 bolts have fed into these four individual operations or orders here. And we can see what are completed and what are still running. So this genealogy tab here or module here is really the ability to work up and down that visualization of that overall consumption, or what we call our traceability. So this is where we're able to work backwards. If we get a call from a customer saying something failed out on the field, we can track, say, our bolts that failed into the field backwards. We can figure out what other pieces or parts they went into, and then we can remedy the issues with these other assemblies as well. Now, next we'll talk about our time booking app. So our time booking app is really how we can start to contextualize all of our labor data. Now, what we'll see here is a large list of some work that has been completed by this specific user or OpHub admin. We can see that for this specified time frame, they've been working for about 36 minutes. And in those 36 minutes, we can see the specific work orders they've been working on, the specific operations, the machines that they've been at, or the workstations that they've been at, as well as the specific labor type. And then we can also see things like our clock time, our apply time, and then the actual individual clock on and clock off points. Now, as you start to look at a larger data set, this can definitely grow and become more complex. So we also have the ability to drag and drop by order. So maybe I want to take a look at this data specific to that order breakdown. I can also filter. Maybe I only want to see a specific serial number. So we'll take a look at 3010. So here we can see those individual operations and how much time I actually spent on those operations. And then our filter time calculates that all down. Now that completes the discrete demo